And so tonight we are going to be talking about some astronomical software, and to introduce that, I'll hand it over to Wilkie.
Okay, thanks, Brad. So let's see if we can get this all to work. Yeah, it looks like it's actually going to work here. So the software that I was going to talk about first is one that we've used a lot and occasionally referred to in our programs, which is one of the most useful pieces of software. Um, let's see if I can get this. Okay, seems to be here.
Looks like
Yeah.
looks good.
Stellarium. Hopefully everybody can see that.
Yes.
So this is the main website. This is the actual program. When you go to their website, and as you can see, it tells you what formats or what operating systems are available here: Linux in various formats, Mac OS, Windows, and there's a web version. But unfortunately, no iOS. But there is an iOS separate app which they talk about too. The PC versions and just using the web, obviously, those are free. They accept donations. This was started quite some time ago by a group in France, actually, but I think it's had participation from all over the world. So this is a good example of what is the term used for group effort? Software.
Open source.
Open source. Thank you.
Yes.
Right. But so let me go to the program, and I may have to get back to make sure that people actually see it first. That is the get to my actual software. There we go. So can people see this, or do I need to get out and get back in? Can you see a screen with Orion on it? Or are you seeing
Not yet, Wilkie.
Not yet. Okay, let me get out. Let me get back out, and then start back in, and I will do it from here because I've had that problem and I've done it before. How about now?
Excellent.
Okay, good.
Oh, yeah.
Yes, we can see
We
it.
got it.
So now you have it. Okay.
I can see it. Yep.
So this is now the actual app that I've downloaded. As I said, the PC version. And it's an extremely detailed software. As you can see, with zooming in, it has many, many deep sky Messier NGC objects, both identified and even with the complete, with photographic examples. Bernard's Loop, see here, the horse head, obviously M42 down here and so forth. But the on this version, your controls are mostly by icons on the left and towards the bottom. And you can set up a lot of your information here, your date, your time, which you can move around, your search for objects, configuration, which allows you to do all kinds of things like put the kind of information you might want to blank out while you're looking up an object if it's too much for you, and so forth. Usually what I find this most useful for is, let's see if I can get rid of this configuration. Configuration, there we go. And here, there we go. Is planning observing sessions in various ways.
Yep.
Let me see. So first thing I always want to know is sunset, sunrise. Well, one of the easiest ways to do that is, of course, is to go around close to where your sunset or your sunrise is, and find your time, and go to time in the morning or the evening, and look for your sun at. Let's see if I can get a time here. Yeah, set time for now. Configuration. Let me do this. Actually, I'm on the other app at the moment, and look for the sun being 18 degrees below the horizon, and then you'll know up until that point. That is complete dark sky according to astronomical nighttime. Don't have it right here at the moment. And then the second thing I do is looking for objects that I'm interested in finding and observing and getting the data that I need from that. For example, if you go to M42, you get all this data here, and from that configuration window, if you want to knock out some of it, you can. But some of the key things here are the altitude and azimuth, especially the altitude, because you go over here and you see it's, oh, this is 38 degrees up, so it's in a very good spot to find. If it was on the horizon or another spot in the sky behind trees wherever you couldn't find it, you'd be able to know that. Then of course you have the magnitude, which is important depending whether you're doing it visually, binoculars, how big your scope is, and then the size of the object is critical. And they don't always give the exact, sometimes the apparent size is what I'm talking about, the size in the sky. Interestingly enough, it has lots of satellites. You see that? Starlink 2096. And maybe Brad can tell me later or he gives some input on this. I'd like to know how to turn the satellites on and off because they get annoying at times. So,
I'll mention that.
You mentioned it, you know that.
Okay.
It also has meteor showers and so forth. Let me go around to, I'm trying to find a nice galaxy to us here. Get up to north, here we go. And let's look for 81 and 82. So, okay, here's Bode's galaxy, M81. And again, you've got magnitude 6.9. We're almost 7th magnitude. But then the other thing that's critical to know is how big and what is the surface brightness. They actually have a little scale for this surface brightness for magnitude per arc minute squared. Or another just more general way is to look for the size and compare it to the magnitude. And here they'll have size is 26 arc minutes by 14. I think that's actually arc seconds, actually. And so comparing its magnitude, how bright it is, and how big it is critical because you may have something that seems bright enough, like M80 101. I'll show you a quick thing with M101 here. Find 101. Here's the dipper. Where's our dipper? And you'll see the.
It's on the right.
There we go. There we go. There's 101. There you see that I don't have a star near it. This has everything listed here. Brighten it up. There's 101. Yes, Pinwheel Galaxy. So again, you get the magnitude 7.86. You say, oh, that should be easy. Well, maybe not your telescope because it's also huge. And you go down to size and you see what the size of 20 arc minutes by 26 arc minutes. And then that same size brightness thing is also extremely useful when you're going to planets. You look for an object like Mars or Venus. And Mars, of course, varies tremendously. And you can see now Mars is getting smaller and smaller and smaller. But when we had opposition, you'd have it at a much, much bigger level. I'm trying to find my time thing. Let me go back to the...
It's on the left, Wilkie. It's on the left. It's at the clock is the time.
There's the clock.
Yeah.
There we go.
Okay.
That's our time date. The Julian day. I don't have our time.
The time is on the right. 21:28.
Oh, here we go. Okay, yeah. 21. And of course, using some of the objects like there is a find feature, so you can actually say Mars. Go in here. Whoops, got the wrong one here. Control. Again, it gives you magnitude and also gives you relative size. Let's see. Unfortunately, it's way down here somewhere. It should be pretty small right now. Can't see it right. That's why it's useful to turn some of these data points off. Let's see size on this one.
It has an apparent diameter. It's like the fifth one.
It should have. Here we go. Apparent diameter 5.78. Right. And then as you really zoom in, of course, you actually get the face showing, which is very useful on Mars to show exactly what features you're going to look for, or on Jupiter, the red spot, or with location of the moons of Jupiter. And then for daytime observing, I've actually used this feature if you want to look for Venus and possibly even Jupiter during the daytime, which I did way back when the comets crashed into Jupiter in the 90s, and I had to find Jupiter in the daytime, is to look it up during the daytime on Solarium and get the exact height, this altitude, the Azal, I call them the Azalt here, what degree of the compass, and how high is it. And by doing that, even with a Dobsonian telescope, you can usually, with a little work, find Venus and possibly Jupiter during the daytime. I don't want to say a whole lot more on it. Has all the Messier objects and a great number of the NGC objects. The detail in each one with links to Wikipedia. If I go back to I'd like to go back to the web version, but I may have. Can people see a web version now, or are you seeing the old version?
No, we need to go out and go back in.
Okay, I'll have to stop share, go back in, and get the web version, which has a lot of the data. Doesn't have as many features, but it's still quite useful.
Can I interject something?
This is Stellarium Web. And as you can see here, when you click on an object, you don't get quite as much data, but you do get the size and you get the altitude, which is critical, how high it is and where it is on the compass, rise and set. You also get a link to Wikipedia. And this is purely web-based. I find I've used it a little bit on an iPad tablet, and without having a mouse, it wasn't quite as useful, but it does work.
Yeah. Wilkie, Art had a question.
I've used Stellarium, Windows-based. There's a portable app, which means that you don't have to have it installed. And if any of you travel and clients, they lock you out, you can load this portable app on a USB stick. It's as functional as what you were showing, Wilkie. I've used it. I honestly don't remember when that became available, but I'm now retired, but it's been at least 5, 6, 7 years. Plug it into USB, and you have full functionality. In traveling, it's the USB versus taking a computer with you. It's usable anywhere in a hotel. Plug it into
if you plug it into their computer, you mean?
Yeah, exactly, and it's fully functional. It's really a great app. I mean, it's really, like I said, what you've shown is it's very helpful.
Right. Yeah, I find, and of course, with having an app, whether it's the app on a PC or even the pay-for app for a smartphone or tablet, of course, that way you don't have to be dependent on the net. So if you're out in JGAP where the internet connections or even the smartphone connections are too good down in Hocking Hills.
Yeah, the portable app is independent of that. I mean, it carries all of what you would have when you installed it into your Windows laptop, whatever.
But I found the PC version, of course, if you are able to take even a small PC or a netbook, I found very useful. And the other thing I've used it for is just planning trips when going to Florida Keys or out west. And I want to say, I'm going to be somewhere in August or September, and I want to see what the sky is and what the best objects are, especially if you're changing latitude and you're down in the Keys at the Winter Star Party and you want to find out when Omega is coming up or some place like that.
I've used it in New Zealand. So, yes, it's fun. Yeah. It's really a cool app.
I think on the web version, they just say near me, and then you go to a map here. I don't think I've tried playing it with this one, but
Omega starts coming up around April, May, and it's pretty easy.
Right.
Very easy in Florida.
Yeah, it is. Wilkie, you use that little target there, and you drag the target onto the map.
Yeah, okay. Oh, you got to drag it.
No, and you take, you can, the little target, not the little pointer.
I see, not
the
pointer. Okay.
Or you can type in an address. Yeah,
you can, that's true, you can type it into it. This again is using the web version, so I'll go down to the Keys there again. So hopefully now we'll use this location, should be here.
in the ocean.
I'm looking for Canopus.
Yeah, there it was.
Just had it.
Canopus is visible already, even in January.
Oh, there it is. There it is. Okay.
Yeah. Second brightest star in the night sky.
Right. And of course, this time of year, Omega Centauri, when you're down, if we were down in the Winter Star Party in the Keys at this time, so it's something we'd be looking for. I don't know if the search will go by Omega. I've forgotten the number of Omega. Open cluster.
So that's a mega nebula. That's a swan.
Okay. It does have some
Omega
Just type in.
Nebula.
Anybody know the number?
5.
NGC.
Just type in Centaurus.
Ain't no mess there.
Type in Centaurus. It'll search by.
It's near NGC 5185.
Yeah, it's Centaurus A. What is that?
Centaurus A is a galaxy.
Centaurus A. That's close to it.
My 8-year-old grandson is starting to rattle off NGC numbers at me.
Pretty good.
He doesn't know what they are, but he likes to read off those numbers.
Gee, it sure is a lot of them.
I'm not sure. I think that it's an early morning. I'd have to set our time for about 3 in the morning right now to get Omega. Which, interestingly enough, the time on this is quite different because you move the there's a little slider you move around here.
I've seen Omega Centauri in either late May, April. Late March, April.
In Ohio, if you have a perfect horizon right now, about 2 in the morning, it's about 2 degrees up. So yeah.
Tell me who's going to have that around here.
Part of my time is blocked off by all your photos.
Yeah. So Wilkie, I've prepared some more detailed information about Stellarium. Do you want me to take over on Stellarium, or do we want to go to Jim?
I don't think, as far as I didn't have a whole lot more to say. Finding the object, the brightness, and how big they were, and planning trips. Also, taking trips back in time is very interesting with it too. I found it's extremely useful. So, do you want me to leave this one or the other up, or shall I?
I can stop sharing your screen, and then I'll share my screen.
You can go back.
Okay. But, give me a sec here. I will start to share my screen. So I use Stellarium a lot. Let me pull it up here. I have this is another program I'll talk about at the end. This one's called Universe Sandbox. I'll need to bring up Stellarium because I can't run all my software at the same time here. Oh, it's taking a second here. Sorry about that. For some reason it was not on. There it goes. It's coming up.
Are you running yours on a Mac?
Yes.
Yeah. Okay.
But I'm running about 6 programs at the same time, so. Come on. Six very high intensity programs at the same time.
Have you tried the iPhone app version of Stellarium? Because that I haven't actually tried.
I have not tried the iPhone, but I use the web version all the time. Okay, so let me pull. I got it up here, Stellarium. So mine takes a lot longer to upload because I've put in a lot of stuff here. Oh, there we go. Okay, share my screen. There. Okay, and now I have to share my. Can everybody see that?
Not yet.
Not yet? Where's my Zoom? Zoom. Share screen. And now we will be seeing Wilkie. There. Okay.
There you go.
Okay. There we go.
Yeah.
So that's the web version?
Okay. So this is the actual app here. So I use Stellarium very often for a lot of different things, and it has a ton of different features. One of the things you asked about earlier were the satellites and that kind of thing. Anytime you have various features turned on and off, they're generally down here at the bottom of the screen, and these are the little plugins that that actually can be added on or loaded or not loaded and that kind of thing. The satellites are this one. So if you want to save up a little bit of memory time, you'll notice that I'm only getting 6 frames per second right now because a lot of stuff is going on my computer. You can turn off the satellites here.
As a plugin, or was that with your original program?
It's part of the actual program, but you can turn it off and on. Okay. So the main things you can do with Stellarium are all under 2 places. There's the 3 places. There's the configuration window, which allows you to turn on and off these plugins. So these are the various options here that you can turn on and off. And satellites are right here. If you want to get the latest set of satellites, you can go into satellites here and then click on configure, and it will download the latest satellites for you. It'll actually go through the whole process. Another thing that's useful that a lot of people do is if you go into the solar system editor and you choose configure, you can download recently discovered minor planets, Kuiper belt objects, and comets and that kind of thing. So you go under configure here and it comes up, and you can import. This is the thing where you can actually import and replace the objects, or you can add them one at a time. You can actually go through here and say, I just want to put this object in there and look at it. If you don't want to put every single possible asteroid in there, you can do that. You import them from the internet. You choose this little import here. I won't do that because it actually takes a while, but you can click on that and actually import all of them at the same time, and that will, if you have all of them going at the same time, it has to compute the updated positions of every single thing in the solar system, and so it does.
So Brad, is that in other words, you're importing this, but you're not manually entering elements, because I think in early versions of Stellarium, you pretty much had to go and put in all the data.
Correct. So this is what you do. You choose download a list of selected objects from the internet, or get orbital elements. You can actually just choose get orbital elements, and you do it separately for comets and asteroids. So if you want all the new comets, you can go comets, and then you choose get orbital elements, and that will actually download the orbital elements automatically and put them in the thing. It'll take every single comet that's currently reasonably bright and put it into your software. So that's a very useful function. There's another. Hello. My system is very slow right now because I'm running a bunch of programs, as I've told you already. There we go. The other thing is you can actually let's see, extras. This here, star catalog updates, is another thing that I've done a lot of. You can download deeper and deeper catalogs. If you have a lot of hard drive space, and you don't care about downloading a really big file, you can get stars down to like 20th magnitude. So the next level, I've gone down to level 8, which takes the entire Hubble guide star catalog and puts it in your system, and that's stars all the way down to magnitude 16.5, which I don't think I need anything deeper than that. If I were to get the next one, it would go all the way to magnitude 18. And then there's actually a 10th one that you can download online, which is several terabytes, which gets down to like magnitude 22. It's huge. But that one's not part of this thing because they don't want people accidentally downloading it. The next one, you'd get 92 million stars in this particular one. And you can
on the satellites, was that an all or nothing too, or are you getting all satellites or no satellites?
I think you're getting all satellites or no satellites. You can download some of the satellites if you want when you go into satellites and choose configure. I think this is you can actually choose which satellites you're interested in. You can go through here and select a range of them and download them, into the system. However, the easiest thing to do is just to download all of them. If you want to just download the ISS and a couple in the...
I didn't want all the Starlink. So.
Yeah, so you can delete all the ones that you have and then download just a few of them, and that kind of thing. I usually just download all of them because I'm, if you got the computing power, you can do it. So it used to actually predict iridium flares, but now there aren't that many iridium flares right now. You can turn on and off whether or not they're labeled, which ones they are and whether or not they're space junk and that kind of thing. You can also turn on and off the orbit lines. If you turn on the orbit lines, what's really interesting when you do that, I won't do it right now, there's a line that goes through the center here, right along this path right here, which is all the geosynchronous satellites. There's hundreds and hundreds of geosynchronous satellites that'll be listed. So a lot of these things you can go in and load up. One of the things that I thought was really interesting was historical supernova. This is a function you can actually download a file of historical supernova, and I've set it up already in preparation for you guys. And you can go in and set the time. So I'm going to set, and you guys can tell me which supernova this was. 1054. And it was in
July 4.
It was July 4, yeah.
The guest star.
Exactly. James has got it. Okay, so it actually started up a couple days before that. So I'm going to set the time, and I'm going to look into it was in the morning sky. So I'm going to wait till the here's the moon, and right there is the supernova. So the supernova, roughly about the same brightness as the moon, coming up, and there's the supernova. Now, if we zoom in on the supernova, you can do something really interesting here, that the software is sophisticated enough. So let's zoom in on the supernova, and it tells us that it's magnitude -5. It's not yet to its full brightness here. So let's get it. Now that's magnitude -6. Here's the day when the moon and the supernova were right next to each other. That was kind of cool. So, but let's say I go the year before. I'm going to click on the supernova, and I go back 1 year. You'll notice there's nothing there. It's gone. It's sophisticated enough to know not to put it there in the year before. And watch what happens when I go to 1055. And I zoom in, you get a sort of pseudo crab nebula. This is the splat from the supernova from the previous year. So
crab nebula.
Yeah, so it's the crab nebula. So here's in 1054, here's in 1055, and then if we go to 2021, and here we go. Let's. It's too close to the horizon right now. I'll turn off the ground.
The horizon.
Yeah.
Sometimes I do that.
We have a bit of drift from the precession of the equinoxes from that amount of time. So I'm going to turn off the ground, and I'm going to turn off the atmosphere, and you'll be able to see it. So there is the Crab Nebula in its place. Okay, and as I was mentioning, what's a nice feature of this program is you can have a ground. You can actually have a foreground, and there are a number of different foregrounds that you can set. You can set the sky and viewing options under a place called landscape, and there's a bunch of different landscapes that you can set. One that I actually downloaded here that someone made was Cherry Springs State Park. Someone did a landscape for Cherry Springs. I'm thinking of trying to figure out how to do one for JGAP. You can actually you can create your own. And so this is the pine trees at Cherry Springs State Park, and it simulates, if you want, it'll simulate like the light pollution in that area. It'll actually simulate the sky domes and that sort of thing, which is kind of cool.
You can create a custom ground contour based on your own photos.
Yeah,
yes.
I've seen that. I haven't done it yet, but if you know how to do that, Art, that would be awesome if you could show us. So getting back to something somewhat more simple things that this program could do. If you want, you can go anywhere you want on the Earth. So this little guy up here at the top tells you the location window, and you can just take this little arrow here and drag it wherever you want. Click on it, and so I'm going to go into the southern hemisphere here in my other hometown, and then you can look at the sky. Now we've just gone from July, and you see July in Ohio or Pennsylvania to July in the southern hemisphere, and you'll notice that you can see all the way down to Rigel, Centaurus, and Hadar. This is the southern skies here. You can see how much higher up the Milky Way gets. You can see there's the Southern Cross right there. To make it clearer, I'll turn on down here. You can turn on the constellation lines. You can actually turn on the actual lines. There's the Southern Cross. Have you seen it for the first time? And you'll notice that we're looking almost, here I will turn on the Azimuthal Grid, which is the lines from the horizon up to the zenith. And they're straight up. So the Milky Way, the center of the Milky Way, which is right here above Shaula, which is in the tip of the Scorpion there, is almost exactly straight up from São Paulo, Brazil, which is where I put myself in that setup.
I was able to catch the top star of the Southern Cross for the first time.
I'm sorry? Go ahead.
When I was stationed in Florida, I was able to see the top star of the Southern Cross for the first time across.
Yeah, it does perk itself up over the horizon. So you can use this kind of as a star charting software also. So if you go into this view page, which is under the sky and viewing options window, and you choose deep sky objects, you can turn off and on labels and markers. And these sliders, actually, if you slide them to the right, there's more. If you slide them to the left, there's less. Hints is just like a picture that there's an object there, and labels actually puts the name on it. So if you go here and choose hints, and I zoom up the hints, you can get all the different objects here. So you're going way up, and you can actually choose which catalogs they're showing. And you could, so if I want to, I can choose all of the Caldwell objects, and then it'll just show all of the Caldwell objects, or it'll show all the Caldwell and the Messier objects, or it'll show, the NGC objects. My favorite are when you do PGC and UGC. Watch out, PGC and UGC. Look at how many there are. So I can zoom in, and there will be tons and tons. It's sophisticated enough to know not to fill the whole screen up, but as you zoom in, there's an awful lot of data. I mean, look at how many of these we've got. So let's pick one of these just at random. And we've got galaxy PGC 5827, and its magnitude 14.4. So this is getting 15.2. This is getting way down. So you can choose a lot of these.
Of next month, Brad, you can just do your Messier objects for your marathon and have only that. Right?
Exactly. So if you wanna just see your Messier objects, you can turn off everything but the Messier objects. So here we go back, and you'll see that the Messier objects are a lot more sparse, given that there's only 109 of them. So here's all of them. And if you if you take the labels down, it'll actually take the names off. You can turn them on here, like that. So these are pretty nice. The other thing, you can turn off and on solar system objects as well. An interesting thing you can turn on minor planets and not minor planets. You can turn on the moons of the different objects. So let's say we want to go to Jupiter here. I could search for Jupiter. Hello. Type in Jupiter. And we will fast forward the time here. And if I zoom in, you'll see that there's 4 moons right now. But if I turn on the minor moons turn on scale. Let's see. Show orbits. And I could turn on the moons here. Scale moons, scale minor bodies, show planet markers. And you'll see that there's a ton of individual objects that show up. It has all 79 moons of Jupiter, but it'll zoom in on them depending on how many labels and markers you've got set. So it's extremely sophisticated in that regard.
Brad, one thing I forgot also that's dramatic is your eclipses, solar and lunar.
Yeah, it'll actually do solar eclipses
very nicely.
Yeah, so it'll simulate the solar eclipses.
Right.
So if we can do that, what we would do was we could set the date to 2017. Wait a minute, 2017, and it was, what was the day? It was August 17th.
Something like that.
Okay.
Wow.
Yeah.
August.
Somebody look up the date of the American solar eclipse here.
Great American eclipse, yeah.
I think it was 27.
I thought it was 17th. But...
While I'm setting this up, somebody look it up.
I can do that. I think it was 27.
2024 is the next one.
Brad,
Yep.
Oh yeah, the 2024. That's a good one. That's Marion, Ohio.
That's right.
So we'll go to Marion, Ohio, and then we'll set it to April 8th of 2024. Okay.
the one in 2017 was on the 21st.
It was on the 21st. Thank you, Mark.
Okay.
So April 8th, and now we'll search for sun. Of course, we're doing this at night, so okay.
Take your time.
You're on 2022, Brad.
There we go. Okay, so let's follow the sun here, and okay, and we'll turn off. There's the moon, and let's watch the moon's over there. Let's watch the moon eclipse the sun here.
Where are we?
We are in Marion, Ohio.
Got it. Should be full eclipse.
Yeah,
Yes.
that's why I picked it, just because it's on the center line.
Yeah.
So here we've got a lovely eclipse.
Web page that'll show this already.
Yeah. So there's we've got our corona and everything like that, and the lunar eclipses will turn red. Those are kind of cool. I've seen those in Stellarium as well. The lunar eclipses are pretty fantastic in this. So here's what the sky will look like on the day of the eclipse from Cherry Springs. Now, there's let's clear up our. I'm going to clear up the lines here. Oh, the problem is I'm showing the orbits. That's why. So one thing that's really useful for this is creating ephemeris for creating star charts, basically. And I did a star chart a little while ago where I calculated. You can actually choose an object, and usually it wants you to input the actual catalog number. So this is a comet that was discovered earlier this year. It's Comet Leonard, and it's supposed to be pretty bright at the end of the year. This is one of the next big thing that may or may not happen, and its best time is going to be in December. So what I did was I simulated from April to let's simulate from you can actually click on it here, 2021. From April to 2021, we will simulate 12/31. Okay, and then you choose calculate, and you can set how often you want the little marks to be, and then it will actually create on the sky a map that is, there it is right there. So this is the position of where the comet will be, and if you zoom in on it, you can see where the comet's going to go. It marks them in kind of a funny way. It uses Roman numerals for the month. So there's August 1st, and then 15.48 is the estimated magnitude, and then the 1 is the day. This is that would be April 8th, magnitude 17. So let's boop up a little bit further through the year here. In a little while in the future, we'll get the better times here. So here's November 4th. It'll be getting brighter and brighter and diving toward the horizon, and so you can actually make really good star charts by putting in the object and then telling how often you want it to produce the little fiduciary mark. So on December 4th, it's expected to be magnitude 6, so to speak, and it should be getting into naked eye brightness by the 9th. So this is actually a pretty useful tool. You can do this for minor planets. You can do this for the moon. You can do it for the sun. Whatever. You can actually predict where these objects are going to be. So it's a pretty nice and very sophisticated
Brad,
piece.
If you make a chart like that, is there a print screen option?
There is actually. What you can do is you can invert the.
Yeah,
you can
you
invert
it. You don't want all the black ink there.
Yeah, so you can actually change the. It's on here somewhere. You can actually change the view. I don't know precisely where it is, but I've done it before. You can invert the image.
And then you do just a screen capture print screen, or
no, it actually creates a chart that you can then just print.
okay.
So, but since I don't know how to do it off the cuff, I won't waste your time. So, if you hit the space bar, it'll actually center up the object that you're currently selected. So another little useful tool that I like is you can input your eyepieces, and I'll have to.
Yep.
Right.
Yes.
I've used that.
You can
Right.
put your eyepieces here. I'm going to move this over because it's behind all our pictures. So I've put in a couple of different eyepieces here. Here's a 40 millimeter Plössl on an Orion Star Blast, and if you click on the little object here, you can cycle through the telescopes that you've put into the object. So you can tell it what the focal length of the telescope is and that kind of thing. And so there's a C14. I also put my obsession in here. Here's the 28-inch at J-gap with the f3.9 28-inch. And there's my personal 8-inch Dob. And then you can change the eyepiece as well. So this is a 40 millimeter Plössl with a fairly narrow field of view. And I could put my 5 millimeter 82 degree Pentax, or 10.5 Pentax, or 14 Pentax, so you can go through and it'll simulate actually how wide the field of view is, by changing the size of the little circle. Another interesting thing that it could.
Brad, also the Telerad feature, which allows you while you're using your finder to know how many degrees of when you're star harping.
Exactly.
Something is. So there's your Telerad view.
So right, if you have a Telerad on your scope, which a lot of people do, these are the rings for the Telerad to give you an idea of how much you need to offset in order to star hop to that particular object. This also has built into it, which I have never used. It actually has a system for manual control or automatic control of telescopes. You can actually go into this. There's a plug-in which is. Wait a minute. It's under. I think it's under Tools, and hold on just a second. Extras. There is actually a tool, I promise you, that allows you to actually use this as a a device for finding the different objects in the night sky. I personally have not used that particular function.
If you
But
have the adapter cable, it just automatically kind of does it. What's nice is you don't have to look up any objects on your hand controller. You just point to it with the mouse, and it slews right to it.
And it slews right to it. So it's basically an all-purpose setup. Here's where you actually set up your telescopes and eyepieces and that kind of thing. So what you can do is you can actually add a new eyepiece. You could type in, 18 inch, and then you could tell it what the focal length is, and 2020, and then diameter, and then you choose add, and there it is. It actually adds that new thing, and then you can add your eyepieces here. I put some eyepieces in there. The other thing you can do is you can put in sensors. You can actually put in the size of, like, the sensors on your camera and that kind of thing. It will actually, and it'll compute the size on the sky. If you go over here and click on that guy right there, this is a standard setup. This is actually our ZWO camera at the JGAP that I put in here, and it tells you how big the field of view is.
With a specific lens, I assume, right?
Well, it knows what telescope you're on.
Right.
Oh, for a telescope. Okay.
So what I can do is I can change the telescope. So it knows the field of view of the area. So as you change the telescope, it will change the it'll change this. And
so can you do that for 35 millimeter camera lens?
Yes, you can. You have to put in the focal length of the camera lens, and then you put in the size of the chip, which is 35 by 24 millimeters, and it will it'll actually give you the ability to pre-plan your photographs, which is pretty cool. I mean, it's a very sophisticated program. The other thing it'll do is it'll actually simulate meteor showers. So I've liked this. If you put it on November 17th of 1833 or 1866, you'll get a ton of meteors. Let's see, 1866. And
just do 2001. It wasn't.
Oh yeah, there was a ton in 2001. November 17th. I've turned on the meteors, and then you just watch the sky, and then the meteors just kind of happen. So let's see. Let's go back one day. Come on. Do I have to turn them on? Let's see. Sky and viewing options. Sky, and then you turn on. Nope. Solar system objects. Show trails.
It's a really robust program.
Yeah. Oh wait, this is how you turn it on. Turn it on. Right.
There you go.
Right there. So we should be getting the Perseids. It was 2001. That was the good one.
2000 and 2001, I think both were.
Yeah. Good. So this is the night of the Leonid meteor shower, and if you just wait, you'll see a meteor happen every once in a while. You can download this program and try it yourself. It does work. I've actually been sitting here, and we'll see a meteor occasionally go by on the software. I do have the meteors turned on. It's probably not turned on to the full huge storm of meteors that they got. Sky.
Yeah, the number of control, the diversity of what you can adjust is immense.
Yeah. Oh, there we go. Shooting stars. So let's go. Right. There's our shooting stars. I sent them way up here. Come on.
Not yet.
Not yet. Shooting stars. There we go. Atmospheric. Come on. Should be going crazy. Okay, well they're not happening right now.
When it works,
yeah.
It's dramatic.
They never seem to happen when you want them. But I guarantee. Yeah.
2,000?
Yeah. I put 100,000 per hour, so 170,000 per hour. Oh, there was one. Did you see it? Just briefly. I just saw one.
Maybe it is 2000. I don't know. 2001.
Okay. Anyway, I'm going to stop sharing my screen, and I will turn it over to Jim here. We could play with this a little bit more. I have one other software package to show, but I'll save it till the end because we're going on a little long here, and then I can play with that other one after Jim gets to share his. So I have relinquished control of the screen, and Jim, you're up, so you can take care of the.
I'm going to talk about a couple of programs that are much less intense than what we've seen so far tonight, because I thought we were going to talk about programs for beginners. So mine will be much simpler to work with, I hope.
That's fine.
The first one that I'm going to show you is called Clear Sky. It is an astronomy, it's a weather forecast for astronomy. And you'll see that I'm showing the clear sky chart for Perkins, and you'll notice it shows you the percentage of cloud cover, transparency, seeing, when it's going to be dark, and in effect how dark it's going to be. It seems like there's a lot of confusing information, but really all you have to remember, at least for the weather, is if the colors are bluer or darker, that's better. But it also shows you things like how much smoke is expected, what wind is expected, humidity and temperature, and it attempts to forecast this for up to 96 hours in the future, each hour getting one block along the screen. Some of the other features are that you can look at all charts that are available and pick out the chart that's closest to where you're observing. If you don't want to go through a list, you can pick a map of the country, and it will show you how many charts there are in every area. And as you expand the chart and narrow it down to the area that you're in, you eventually get down to the point where it actually shows you the observatories, in this instance, which are near Columbus. I use Perkins Observatory quite a bit because I happen to have an observing site on a grass field airstrip where a friend of mine lets me store my larger telescope, and it's about 4 miles south of Perkins Observatory on the east side of Alum Creek, the reservoir. So I use Perkins Observatory quite a bit. And then, because of that, I have made Perkins Observatory one of my favorites. So I click on that, and it shows me the clear sky chart for that particular location. And they say if you're not within 15 miles of a clear sky chart, you can request that they produce one for you. So that makes it pretty nice. Some of the info that's available, that's their settings, is to add a night vision version of the chart, which helps a little bit, might make it a little too hard to view. I don't use that very often. In fact, most of the time I'll use this before I go out observing rather than at an observing site. I might mention that this is currently an Apple iOS product only. However, there is a website called cleardarksky.com, I believe it is, and you can go in and view all the same information for any of their featured or plotted sites on the website as well.
Jim, if you click on one of the hours there, usually you should be able to also get the projected clouds. I don't know if you click on an hour or any time, just click on one little square. Yeah. At least on the online version, it does that.
or
Yeah.
maybe not.
Maybe not on, if you click on, say,
Double click on
morning, 3 in the morning,
any
Well,
place where the
I'm working
cloud
on-
cover is.
it'll
This
give
is
you
on an iPad.
yeah, right. So it may not be, or maybe a
So it
different.
may But beside that, I mean, for me, that's to get a general trend is good enough for any observing I'm going to do. And the other thing that you can choose to see, you notice down at the bottom, you can either show the legend or not. I usually just leave the legend on for no other reason than I just like to have the legend there. But that tells you what each of the colors for each of the categories of information actually mean. So that's Clear Sky Chart. The other program I want to show you is called Go Skywatch. It's another planetarium program. There is a free version as well as a paid version. The difference is $3.99. And with paying for it, you get rid of the advertisements. I'm showing the version I was showing you with the settings. I will turn that back on in a minute. You can see that it will show you the actual night sky where you're located. I've got it on a stopped clock version, if you will, so that I don't have it. I don't have to point at a particular part of the sky. Hold it over my head. Notice I've got it pointing sort of down right now because I have it sitting on a desk next to me. But we can pull it up. We can zoom in on an area. If you go to a particular object, it will give you an image of that object. You can also, if you decide you want to look, if you want to look at the sun, you can see what the sun looks like. However, it's not a real-time image of the sun.
Right.
And if you want a little bit of a wow feature, you can actually say planets, and it shows the planets bigger. Like I say, that's kind of a wow feature. I'm not sure that that's helpful that much. It will also show comets if you want them, if there are any in the sky. You can turn off deep sky objects if you'd like. It also has a night mode version. You can show coordinates either in celestial coordinates, and it gives them to you in the lower part of the screen there, the one that has like a little compass shape around it, and that shows you the right ascension, and up and a little bit to the left of that is the declination, or you can show it in Alt-Az coordinates, and those you turn the celestial grid off, and it shows you in compass degrees and altitude. Notice those two symbols before have now changed to a compass and an eyeball, or maybe that's a device showing latitude. I'm not sure which. I like to call it an eyeball. You can also turn the horizon on and off. You can show a horizon grid, shows you the altitude and azimuth coordinates, and you can add the celestial coordinates to that if you'd like. You can also show star color, but I haven't had too much success with that. Of course, well, most astronomers, at least once you've learned a little bit, you recognize that star colors are more really faint pastels rather than bright colors. This is also available only on Apple products. There are companion products. One is called Go ISS Watch, which is a free product that will show you when the space station is going to go over your area. There's another product called Sat Watch, which costs a little bit of money, which will give you satellite predictions and show them actually going over at the indicated time. They claim to have a product in the works called Go Sun Watch, which literally is an app for the Apple Watch to tell you when the sun is going to set and so forth. And I think that's all I have to. One other thing. You can set up locations where you would like to observe from. I think that's what this. Well, this shows you where you are observing from. There is a clock function for you to set up the date and time that you want to observe. There's also a search function. I forgot to mention that, so you can search for any of the objects that constellations, planets, any deep sky objects, individual stars. Starlight tells you when the light from the star that you are viewing left that star. So in effect, it'll give you an idea of how long it takes light to travel from that star to your eye.
That's nice.
Will also show you comets, or you can search for comets. That's the majority of the features in a nutshell right there.
Jim, could you zoom in so we could see how many stars are in the catalog?
It goes down to about magnitude 6.5.
Okay. So it's kind of a Norton star atlas.
It is for beginners.
Okay.
Right. But Jim, also, if you center an object in your little circle there, doesn't that, it gives you the main information of that object, as I remember, the altitude, the azimuth. And at least on my I have a version of it. It also has a link to Wikipedia's article about it and everything. And maybe it's a little different version. But
I like the light time feature.
Okay,
that's really neat.
Yeah, there you go. So there's the altitude, azimuth, magnitude, distance, all of that, and then Wikipedia next door.
Not an overwhelming amount of material, information. More for beginners. But then you've got to remember that you're looking at it possibly on an iPhone, so you want to be careful you don't overwhelm the screen or the observer with information.
I was using it on an iPad, so.
Well, I'm looking at it on an iPad. This is from the iPad, but even so, that's my personal preference. I don't go too deep.
What I think is nice about it is I think the interface is very elegant and easy to use. You don't have to dig too deep to find things, as we've found.
Correct.
Yeah.
Mm-hmm.
Yeah, I've often used it for the same thing. I was talking about stellarium, and I want to quick say, is the moon still up, or when does the sun rise, or how long is it going to, when is it going to get totally dark? I often use Go Skywatch for that.
Here is the free version. You can see a little bit difference in the interface. It wants to, well, you've got to get the money somehow.
Cool.
There you go. Any other questions that I might not be able to answer?
Looks good, Jim.
Okay. Thanks, Jim.
Mm-hmm.
Wilkie, I have one more piece of software to.
Oh, that's right. Yeah, but this was not a planetarium program, but something a little different.
This is something a little bit different here. This one's called Universe Sandbox, and it is a commercial product. It's available across platforms, so you can get a Linux version. You can get a. Can I share a screen now here? Let's see. Share screen.
You're on.
Let's see. Share screen. Let's see. Share. Okay, so here's Universe Sandbox. This is it's a commercial product. I set the $50 or $29.99, $30 to actually get the full experience and everything like that. It's actually it fancies itself as an educational tool, but what it really is just a lot of fun. It's a program that allows you to play with gravity. And by that I mean you can take planets and slam them into each other. You can put a black hole at the center of the universe. You can smash a bowling ball into the Earth at the speed of light. You know, you can do whatever you want and find out what happens. And what it will do is it will compute the climatic, geologic, temperature, orbital effects of those different functions. Now, it is, first and foremost, it's a simulation of the solar system. It has a very nice solar system function. It has a rich community of people that actually set up different scenarios for this, so you can actually go and download. So what you can do is you can actually zoom in on an object. Let's see, I'm going to zoom in on Earth, of course. So here's Earth, and see what Earth is up to. And the simulation down here in the corner is going at 21 hours per second. So I can speed that up and slow that down. I can actually slow it down to real time. So let's see here. 1 second per second. That's 59 seconds per second. There we go. 1 second per second. So there's the Earth. If I load this particular program, there's actually a existing simulation that I've downloaded, which is called Solar System Here and Now. Right? Yeah, now in real time. So this is actually the current, as best it can go, the current layout of the solar system. So I'm going to go in, and if we look here, you know, North America is currently, here's the sunset line here. It's 9:30, and so we've gone, you know, the Earth is turned all the way around here. The planets are in the right location. The moon is nearly opposite. Okay, so there we go. So if we go back, we can see, where Mars and Venus and Mars and Jupiter are. Jupiter is almost in line with the Sun right now. You can see, so it's opposite that. So it's a good, just generic simulation. So the strength of this particular program is in just doing fun things with the different planets here. So we're gonna abuse the Earth here for just a little while. So one of the things you can do is you can actually go in and take a look at all the different features of the Earth. So let's see what happens if we were to take the Earth, and so you'll notice that it tells you all the different aspects of the Earth. One of the more interesting ones here is the average temperature. So let's take the Earth and see what happens if we double the mass. Okay, so, or make it 10 times the mass. Okay, so it gets to be bigger, and see if that affects the climate at all. So let's speed up time and see if the temperature of the Earth actually changes over time. And I bet you that it actually will. So we will go and we will fly through the simulation here, and we'll watch the average temperature change. Okay, we got to go a little faster than that. So see if the climate actually changes on Earth. It's going down it's going down a little bit. It's going down a little bit. Okay. So So let's slow it back down again, and we will do something interesting. We will actually add another object to this. We've got the moon already. Oh, first of all, so now the moon is gone because the mass of the Earth multiplied by 10, and the moon got flung out of the solar system. The moon got flung out of the solar system. So let's add an object, and what do you say? What do you say we slam Mercury into the Earth here? So I'm going to slam Mercury into the Earth. Okay. And let's see, I will take and launch this. Slam Mercury into the Earth, and let's watch what happens here. We'll zoom in. boom, we get a huge simulation here, and we splatter out. And now if we go back and we take a look, we'll slow down the simulation a little bit. The simulation is better if you do it more slowly because it's more precise. And let's turn off launch and get rid of that. And we will see what the temperature of the Earth is now. So we will go up and we will see the average temperature. Oops, hello. Average temperature of the Earth is 1,500 degrees Celsius, as we've smacked the Earth with a large planetary body. Now, if you watch this over a while, this will slowly progress over to over the entire surface of the Earth until the entire surface of the Earth glows.
Have you tried it with more realistic objects like the Tunguska?
Yeah, you can,
or something, and see how close it got to what happened. Or
yeah, I've done that before. So let's slam an asteroid in there.
Can you take Mar-a-Lago and like project it out to the heliosphere?
Sure, let's do that.
Yeah, I'd like to see what happens if it turns like all orange.
Okay, so I just reset it. Okay.
Climate change. It's a myth.
So let's double click on Earth and zoom in. One cool thing you can do, if any of you guys are like Star Trek fans, you can fire a laser at Earth, a la the Borg. So let's go Tools, Laser, and here's the wattage of the laser that it's currently set at. This is Yato watts, which is, I think, 15 zeros, if I recall correctly. And so if I point this at the Earth, I can just fire a laser at Earth. And this is, then I can take a look at the temperature here. If I click on this guy right here, I can actually change what it's showing me on this little map here. And that little dot there is actually a heat map of that particular portion of the Earth. And right now it's at 30,000 degrees. With a 4 Yato watt laser. So we've just Yato watt lasered the Earth. And this gives you the ability to see the effect of an impact. So if you want to, instead of just having an impact, you can actually just fire a laser to simulate what happens when you heat up a certain portion of the Earth. Now gradually what will happen is, I have to turn off the laser. Hold on. I'm still...
Just evaporated Donnie and Ivanka.
Yeah.
In bed.
They were in separate beds.
No, they're not.
Yeah.
Evaporated my home in Puerto Rico. Come on.
So if you simulate this, one thing that's kind of interesting with Earth is you can what it will act, the water will evaporate. So you can actually change the climate of the Earth here. So let's do overview. The one thing, surface, and if you go down and choose sea level here, you can actually, if over time, what'll happen is you can change the sea level over time. But to speed that up, I'm just going to change the simulation. And what's interesting is if you take all of the water away, the Earth gets a little bit cooler. On average. Of course, we've got that hot spot over there throwing off our average. But you'll notice that the entire Earth freezes up. If you take the global warming gone amok, all of the ice melts from the Himalayas here. This is the Himalayas. And it all disappears. Now, if I take it back down to 11.5, you'll notice the ice comes back and that kind of thing. So it's pretty sophisticated. It actually knows what the effect is on the climate. So let's take our little Tunguska event here. I'm going to reset this so we're not thrown off by the. I want to restart this particular simulation here, and I'll zoom back in on Earth. Okay, so here we go, and. Whoops, you have to double click. There we go. Double click on Earth, simulate, and zoom in on Earth. It's very simple. Okay, and Tunguska is over here somewhere. So we will fire an asteroid. We'll add, let's see, which asteroid do we want to do here? There's a bunch of different objects that you can throw at it.
Arrows.
Okay, arrows. That's a good idea. For you, you've been watching The Expanse, have you? Okay.
Well, that was the first asteroid we landed a robot on.
Okay.
Then the Japanese did a couple asteroids since, and then
Apophis is
we've
one
had
that always
orbiters.
is going to hit us, right?
Yeah, Apophis would be interesting because, okay, so well let's fire off Apophis. Okay, I'm gonna fire it off here, and actually I just fired 2 Apophyses, so we'll see how long it takes to. Okay, so there it's going. This is its actual speed through space. So we'll speed things up a little bit here to make things go a little bit quicker, and then I'll slow it down when it gets to. It's breaking up, and I'm going to slow it down so that we can actually see the impact.
That's both of them, right? The 2 Apophis.
Yeah. So let's. I just fired off another one here. Okay. There we go. Okay, so we're going at about 15 seconds per second. This is 15 times faster than what the occlusion would actually be. So there we go. Boom. Apophis, and so there's our. So let's pause that and see what the temperature is in that area here. So I'll click on Earth, and I'll go up, and I will choose the surface here, and I'll zoom out. And where's
all
our?
the trees get knocked down.
I will spin this up here. Can anybody see any change here? So the atmosphere. So it's a pretty big shock wave there. I think Apophis isn't enough to appreciably change the temperature of the Earth. So one cool thing you can do is you can actually cause things to orbit about the Earth. So let's add a moon real close to the Earth. I will add. Let's put Pluto in orbit about the Earth here, but let's put it really close. So what do you think is going to happen if Pluto is really close to the Earth?
Super tides.
Okay, so here's Pluto in orbit about the Earth. Now this is 15 times faster than real time, so it's actually moving, but we need to speed it up to see what's going on. Okay. Oops, I have to hit play. Hold on, I forgot to hit play. Okay, there we go. Hit play. Play. There we go. So now it's moving very slowly in orbit, but if I speed it up, you'll notice something happens here. It's close enough to the Earth that we will start to get a little bit of problems here. She's breaking up, Captain.
Oh, man.
It's inside the Roche limit. So Pluto, orbiting around the Earth, will slowly start to break up, and eventually it'll form a whole bunch of different little objects here. So I'm going to speed it up just a bit so we can actually see the effect. The view that I've got, I'm going to choose orbits instead of trails here. Orbits. Okay. Okay, so we're starting to get Pluto. It's starting to slough off and break up and everything like that. But if we speed it up here, it'll really start to shrink and turn into a flaming torus of material, and things will start to fly in. And so inside the Roche limit, Pluto will start to break up. So it's sophisticated enough to know about the Roche limit. So this so you could do silly things like that, but you could do some really absurd things that are kind of fun. You could do Earth and 50 colliding moons. Okay, so let's put 50 random moons around the Earth and watch what happens. So, and oops, they're colliding. And so we'll get a really interesting effect here of... Now this requires a fairly good computer to simulate. I have a decent GPU. It's about 4 years old, but it's a fairly high-end GPU. If you want to simulate this really well, it requires a better GPU than what I've got. So here's our thing. You can add black holes. You can cause the sun to explode. Let's do that. Let's cause the sun to go supernova here.
It can't though.
It can't. But in this particular case, you can make it turn into a supernova. So let's do.
Can you install an idiot as the president of the United States?
Unfortunately, that's our job. So oh yeah, supernova sun and the it's already built into the system, but you could set it up. And so this is. We'll do a supernova real time here. How about that? Let's restart, and I'll set it to. We're setting it to 1 second per second here. Oh, I want to. Okay, 1 second per second. There we go. And I will restart it. Restart, and I think you have to set the time before you start. There we go. Boom. We'll slow it down. So there's the explosion going on at approximately real time there. Okay, as the supernova. You'll know how long it takes the supernova to overtake the Earth. So there's a really cool feature that I like in this. That is, let's go in systems, and let's choose all. I want to just choose solar system here. Solar system. Okay, that's a good one. Okay, so if I click on the sun, for example, I can actually send out a pulse of light from the sun at light speed. So let's turn this down to 1:1. I'm turning it down to 1 second per second. That's the simulation speed. Okay, so if I go into tools and I go into pulse, the sun will actually put out a beam of light that travels at light speed. So this is the speed of light compared to the sun. So if we back up, here's how fast the speed of light goes relative. And you can watch that rise out. In about 8 minutes, that circle will overtake the Earth, because that's how long it takes light to get to the Earth. So this is a little circle, and you'll see the circle is getting it's very subtle. It's getting bigger. If I were to speed it up, you could see that it actually does go faster and faster. So you can simulate the speed of light from the different objects. And there's all kinds of cool things. There's you can add a satellite. You can actually, if you go in here and choose, I believe there in My Objects. Wait a minute.
I think Ganymede is the largest of them all.
Yeah, Objects, there we go. You could put a bowling ball in orbit about the Earth if you want. There's the Russell's teapot. My favorite one is the sperm whale. You can actually put a sperm, for people who love the Hitchhiker's Guide to the Galaxy, you can put a sperm whale orbiting around the Earth to fall into, or petunias. Do you guys remember that from the Hitchhiker's Guide to the Galaxy? A police box. But the ones I was looking for here were the Tesla Roadster, the Cassini spacecraft, and the New Horizons. So I could put the New Horizons, the Cassini spacecraft, in orbit, and then I can click on it and change its velocity and that kind of thing, and watch it move around the solar system. So if I get rid of that, hello, there we go, and escape. I don't want to add anymore. I put 2 Cassini spacecraft there. There's 1 Cassini spacecraft. So if I want to, I can make the Cassini spacecraft go 300 million kilometers per second. Okay, there we go. So there's the Cassini spacecraft going at 300 million kilometers per second out of the solar system.
Saturn.
Yeah. So that's, and we're going, much faster than the speed of light here. We're going 100 times light speed, so we can go 1/10, and now this is actual light speed. So it's a really fun program. It's basically just a way to play and figure out what if.
This is all solar system, though, Brad. You said
it's solar system. There's also galaxy simulations.
Right.
You
could recreate, for example, the Jupiter comet impact and see what it thinks.
Exactly. You can do that. One of my favorites here is the Milky Way. It has these sort of rough. It has another feature where you can actually collide the Andromeda galaxy with the Milky Way galaxy. So here's Andromeda. Here's the Milky Way, and you can actually collide them together here. So we're going 1.5 million years per second here in this collision. And this, you can see that my computer is slowing down a little bit. It takes an awful lot of computing power. One thing that I've done with these is I've put like a billion mass black hole, in the mix. So let's add an object here, and I will add a black hole. So let's see. There's a black hole. Let's do 10 million solar mass black hole here, and I'll put it at the center, and we will see if that affects the yeah, so see, it got a lot brighter there because there's stuff actually orbiting around. It knows when things are getting sucked up into the black hole. So if I zoom in, I can actually zoom. There's the black hole right there. You can actually see it. And you can actually simulate little star clusters. You can put star clusters together and see how they get disrupted by the galaxies colliding and that kind of thing. You can create nebulas. It thinks of the galaxies as clumps of stars. Actually, it doesn't actually simulate every single point. It simulates them as kind of a bit of fluff, and then it will simulate within those bits of fluff in order to save computing time and that kind of thing. So, but anybody have any questions about that? It's a pretty fun little program. Another very similar program to that I can't use because I'm using a Mac. This is for the PC folks. I don't have it. It's one that just simulates the universe. It's called Space Engine, and I'm told that it requires a really high-end GPU, like a 3080, NVIDIA 3080, or a pair of 970s or something like that, some real beefy GPU, current computer and that kind of thing. But this allows you to travel to any place in the universe, and it is sophisticated enough to, like, if you go to the Andromeda galaxy, it will simulate planets around the stars. It'll fill in the planets around the stars of the Andromeda galaxy with hypothetical planets. It'll actually create the universe that it hasn't filled out with plausible objects and that kind of thing. But the visuals are amazing. You can sit on a planet. You can occupy the rings of Saturn. You can go to any of the known worlds in the universe. You can go to the black hole at the center of a galaxy. You can travel into nebulas and things like that. This is called Space Engine. And what Brian Greer was raving about was that it has a virtual headset version. You can actually wear a Oculus Rift or some other VR headset. I've got an ad here. Sorry. and it will give you a 360-degree view where you can actually see the view all around. And if you travel to another planet and we don't know the details on the planet, it will fill in it'll fill in the planet with plausible craters and mountains and atmosphere and that kind of thing. So that's Space Engine. I'm told it's also $30. If you have a sophisticated enough computer, I'm told it's really pretty spectacular. You can just point at the Orion Nebula and go fly to the Orion Nebula if you want. So here's a hypothetical planet that's near the core of the Milky Way, looking over the core of the Milky Way. The narrator is explaining that this is just a planet floating around another star that he is watching. So those are two pretty cool programs that if you want to spend a little bit of money, $30, you can get them. They're both really fun. So anyway, that's pretty much it. I just felt like sharing that. So if anybody has any questions about that or Stellarium or whatever, just let us know.
I got one about the first one, Stellarium.
Sure.
And I looked here in my own observation book. October 12, 2019, Jason had his giant telescope, motor driven, and twice that night he showed a bunch of us the planet Pluto. And within the field of view, you could see it, but then there were two little stars in the same view. And I've been trying pretty hard to figure out what those two little stars were the names of.
They probably have catalog numbers, but we can look it up.
Yeah.
Do you remember precisely what date and time it was?
Yes, it was. It was two times the same night. October 12, 2019.
October 12th, 2019. And it was in the evening.
Yes.
Okay, so this is how we would do this. We'd pull up the date and time, which is over here. Pull up that little clock. You type in, I could just go 2019 and then boop up to 10, 12, and then I will choose search window here. I'll type in Pluto.
We saw Jupiter and Saturn, and Pluto at the time was in between them, in Sagittarius.
Yeah, so there's Pluto. Okay, so it's pretty low to the horizon early in the evening. So let's zoom in. Now I have all the star catalogs all ready to go here.
Yeah. I mean, Pluto was
next to two little stars here. So we've got a little triangle here. So Pluto was magnitude 14.29 at that point, and the two stars next to it were magnitude 14.9 and magnitude 14.1. So that would have made a nice little triangle with Pluto on that evening.
Well, it wasn't quite a triangle. They were all in a line.
All in a line. So if we want to see, this is pretty good in terms of getting I have the high. You can actually set how accurate you want the calculations to be, and if you set it to the high accuracy, it does a very good job. So let's go a couple of hours in advance and see. Whoops, hold on.
I don't know. I think it might have been 8, 9 o'clock, perhaps.
Yeah.
In the evening.
So, fairly close there.
But it was all in the same field of view.
Okay, so there's the 13th. That's pretty close.
You got to zero in a little bit.
Yeah. So let's go a little bit further here and see. So Pluto, we can actually Oh, if you zoom in even further, you can actually see Charon there. The other moons.
Yay.
So, Nix, Hydra. Now, you would not be able to see Nix, Hydra, and Erebos and Charon. They would be far too close to Pluto. But
Are you saying that I saw Charon too?
yeah, so maybe no, you did not see Charon. Charon is like magnitude 17, and
No,
it's
but
also
there were
1/10 of an arc
stars.
second for Pluto. So
2 little stars.
yeah.
In a line.
Yeah,
in
so
a
there's a
line.
tool right down here at the bottom, which is angular measurement. That little tool right there, and you can load that at the outset. And that what you do is you click on 2 objects. You click on one object and then you drag, and it'll tell you how far apart the objects are. And right now, they are less than an arc second from each other. So I don't think you would be seeing Charon. But you might be seeing this guy over here.
Maybe, yeah.
Yeah.
What's that one?
Well, it's not a particularly bright star. It's a
Either
Hubble
one of
guide
them
star.
will.
It's just a background guide star without a catalog number. So
Huh.
yeah, that's
No name.
yeah, no name,
There
no name.
were 2 of them in the same view.
Yeah. Well,
Pluto.
what's really interesting about this is you can see interesting events and that kind of thing. I often use this to spot conjunctions and that kind of thing. So if we go to the 21st of December of 2020, so let's back up here to the 21st of December.
Yeah, what was the magnitude you said of Charon was?
Charon's like 17th magnitude. It's very faint.
Then I probably didn't see that.
Yeah, so we can go Jupiter here. Anybody know what I'm searching for here? On the 21st of December of last year?
Jupiter and Saturn were
Yeah,
very
Jupiter and
close
Saturn
together.
on the
Yep,
21st of December. So
I
here's
saw that.
the simulation of Jupiter and Saturn. That gives you a good idea of how far apart they were. And if you really want to measure how far apart they were at this point, you've got that little tool and you can drag it and see that they were 6 arc minutes apart.
Yep.
So if you guys know distances, you know that the moon is 30 arc minutes across. So that's 1/5 the diameter of the moon right there.
I saw that. That was the so-called crystal star formation.
Yeah.
Everybody was talking about that.
Yeah. So anyway, anybody have any more questions about Stellarium or the Universe Sandbox or the Deep Sky app? That's actually, or Dark Sky app. That's actually one of the most useful ones, I think, is the Dark Sky app. I like it because it was made by a guy named Attila. That was his. Yeah.
Right. Canadian, right?
Yeah.
Attila Denko.
Judy Clapper raised her hand. Judy, what's your question there?
My question is, could we have a list of the apps that were discussed tonight? Because there was a lot of them, and you know, and we all have different platforms that we're using. So I was wondering if maybe there could be a list, even if that list could be maybe even expanded to like, here's what's available for Apple products or Android or PC or MacBook, etc., etc.
I'll put a link to all the different products that we talked about tonight in the Facebook page. We can also put it on the groups.io.
Yeah, put it on the groups.io too.
Yeah, we can put it on the groups.io and just link. Stellarium is very easy to find. All you need to do is type in.
I have that. I have Solarium Plus on my iPhone. It's like really user friendly, super user friendly.
Yeah.
Yeah. And then the other question was the controversial thing about Pluto is Pluto still a planet or was it downgraded to a star? I'm really confused.
Pluto is a dwarf planet. It is not a planet.
Dwarf planet. Okay, that's
Well, JPL's discussing it though. Because they're saying
It's a matter of definition. It's not a matter of it's still a round body that has an atmosphere and a little moon system, and it always has been a round body that had an atmosphere and a little moon system. We just called it something different. I think it doesn't matter what you call it. It's the reason why people started calling it dwarf planet is because there were an awful lot of other things out in Pluto's area which were a lot like it. They started discovering a bunch of bodies in what's called the Kuiper belt, and Pluto just happened to be the first of those objects that was discovered. And then there was Eris and Sedna and Makemake and Quawar and Ixion and Aruna and tons of other ones that are all some of Sedna is actually bigger than Pluto. Eris is roughly the same size as Pluto, as I believe, and so
Charon isn't similar, or it's smaller.
Charon is like a quarter of the size of it's Charon is the moon of Pluto. It's sort of a double planet.
The biggest one.
Yeah, it's relative to the size of its body. In fact, they don't orbit. The moons don't orbit around. The moon doesn't orbit around Pluto. They orbit around a common barycenter, which is not even inside of the body of Pluto. They actually orbit kind of around an area that's about 1/10 of the way out from the surface of Pluto. And
your answer was perfect, and before we rabbit trail anymore, it sounds like this could be a topic of its own, of planets, dwarf planets, etc. Yeah. Thank you. You thoroughly answered my question.
Okay. Glad to know.
Oh, yeah.
Just so everybody knows, we are going to lose an hour of sleep tonight. So
okay,
we're all late night people. We're all night owls, but just for people that you forgot.
Thankfully, it happens over Sunday.
Is that tonight?
I am not. And with that said, good night, everybody.
Good night.
Good night.
Hey, Brad.
Yes.
I was going to add an interesting program that you may want to add to your list of things. It's called Dyson Sphere Program. Another simulation. It's kind of it's actually in beta, so it's only like $20. But basically, you're trying to to make the sphere that actually encases a sun, and basically is up to you to actually make it work. So for those guys that actually like simulations and things like SimCity and simulations in general, with a kind of a looking into future and science fiction and so forth. Mm-hmm. Again, Dyson Sphere Program is an interesting program as well.
That does kind of cool. Yeah, I like playing with things like that. This is also on Steam. Steam is actually an app designed to sort of corral all of your gaming type programs, and there are a number of different astronomy related programs also in Steam, which is where I got. You don't have to use Steam, but I used Universe Sandbox with Steam, and then it keeps it in a single place. So if you type in astronomy, you can find different types of things. I think there's a Kerbal. Have any of you guys used Kerbal Space Program? Kerbal Space Program is kind of a game which lets you simulate orbits, and it's physically accurate. But what you do is you set up a little space program with these little astronauts here, these little guys called Kerbals, and you can design and create a rocket that goes off the Earth, and it has the right amount of fuel and acceleration, and you can do Hohmann transfer orbits and things like that, and learn about how orbital mechanics works. And it's a lot of people that know about this sort of thing vouch that Kerbal is pretty much got it right. I mean, it's not 100% accurate, but it's pretty close. And so what you do is you can create a little space program, and it's a game, obviously, so these guys are kind of cute and they do funny things. But you can explore a hypothetical solar system with the Kerbals, and so that's kind of cool. And it even gets down to the point where you have to set up a communications network, for example. You have to have the antenna on the right side of the Earth in order to be able to hear the communications. And there's light delay built into it. If the person is out orbiting around Mars, you have to wait 4 minutes before 8 minutes or something like that for the signal to get back, and that kind of thing. It's very well done. But these guys are kind of cute, so the kids like it, so it's really fun. So if you want your kid to become a rocket scientist, this is Kerbal Space Program is probably the program to get for them. So I like that one a lot. I played with it a little bit. There's a free version that you can download. This one is $39.99 through Steam. I got a free version that was crippled, and then after a month you had to pay for it. So I didn't actually pay for it, but so I don't have the full version. But there's a trial one you can actually download if what I did a year ago was correct. So, but anyway,
my kids really enjoyed that, and my son learned an important physics lesson, and that is that parachutes do not work on the moon.
No, they don't.
No.
But retro rockets work very well. So,
Well, they work on Mars, but they have to be 10 times the size, right?
Yeah, they have to be very big, and then you probably still need retro rockets when you get within a few hundred meters of the surface. So, well, guys, it looks like it's kind of petering out a little bit. You're welcome to stay around. I am going to stop the Facebook live stream here. So if anybody's on Facebook Live, I apologize here. But if you guys want to hang out and chat and grouse steak and shake you're more than welcome. But as far as the Facebook folks go, thank you guys for hanging out with us, and we will see you in May with our next planned program. So the next meeting will be Jason Hissong. He's going to be talking about telescope building in May. The next meeting will be in April, and we're intending to go down to the John Glenn Astronomy Park and having an observing session in lieu of an actual Zoom meeting here. So see you then.